Okay, so we're going to do graphing of absolute values. Absolute value equations. Okay, so we know how to graph linear equations, we know how to graph quadratic equations, and that's kind of the first step to this, even though we don't care to see this stuff. Let's just quickly do a example of a normal linear equation like y equals 2x minus 6. We started graphing these in about grade 9, the y equals mx plus b thing, so I'm going to switch so I can do both markers here at one time. Not for you guys, but for the videos. Here's our m, and here's our b, right? So when we graph these, it looks kind of like this. So I plot my y-intercept down at negative 6, 1, 2, 3, 4, 5, 6, and I plot my y-intercept there. And I follow my slope from there, and our slope m is 2, but it's really 2 over 1. So I rise 2, and I run 1, so up 1, 2, over 1, and plot my second point. So that's what that line there would look like. Now, this is at 2, 3, because our x-intercept is 3, and you can find that out by plugging 0 in for y and isolating x, right? You can just put it at 3. It doesn't have to be perfect. Okay, so there's what that graph would look like. But now we're talking about absolute value, and if what we learned the other day there, everything's positive, right? So if I look at it this way, y equals the absolute value of that equation. Well, now the y here, the y value, is going to be the positive of whatever this thing is. So in essence, the whole graph that's down here where y is negative, we make all those y values positive. So where we've got at negative 6 here, we go 1, 2, 3, 4, 5, 6. And you can see where our graph is going to turn and go like that instead. So it's the same graph, only everything that's below the x-axis flips and becomes positive, right? Because this down here, y, is all negative. But because we're taking the absolute value, y becomes positive. So even here at this point here, at 1, negative 4 would become 1, positive 4. Right? So 1, well, I guess my graph's a little off, but you see what I mean. Okay? So that's a pretty straightforward example. Now let's do one right from the start. Okay? You okay with that, Lana? Okay. I'm just going to erase this right now. Whoa. Whoa. And we'll do a quadratic one now, because I don't know why this is, but the assignments or the practice questions that I've got for you are almost all quadratic. And not that they're any harder, but let's see here. Let's go and do this one. Y equals the absolute value of x squared minus 4. So if I suggest anything to you, it's maybe to have 2 colors, a pen or pencil, whatever you're doing your erase or your stuff in, and lots of stuff. You can do this all on a graphing technology, graphing calculators, things like that too. But I like the idea of knowing what it actually is doing rather than just pumping it in. So we know how to graph this because it's just a parabola, right? That's exactly what we've been dealing with all along. So that's the same as saying y equals x plus 0 squared minus 4. Not that that matters. We can do a table of values as well. But just in working form, the vertex is at 0, negative 4. There it is. Our x-intercepts, that's what kind of factoring would that be? Difference of squares, so x minus 2x plus 2. So I know that our x-intercepts are at 1, 2, -2. I mean, like I said, table of values. So there's what the normal quadratic would look like, graphed. But because we're looking for the absolute value, now I'll do your guys in red, but it won't look red. These values that are below the x-axis, they just mirror themselves about the x-axis. So this -4 goes to +4, and it goes like so, right? So for you guys, I'll erase this and just go like this. It goes like this now. There's what the absolute value graph looks like. So it's a little different. Yeah, looks like a W. That's right. So there in the green is our graph of that function. Y does what? The parabola? The parabola is the same graph except any part that's negative, because absolute value tells us, that's right, y has to come out negative if that's the case. So we'll do one more quick example, just because it's not too crazy difficult. I'll throw a little twist in it. You won't see, this is kind of beyond what's expected of you, but I'll show you one anyways. We'll stick with the quadratic stuff because I think it's a little bit more interesting. I like that one. That's a good one. We'll go y equals x squared minus 9. Let's go plus 4. I don't know. Let's just do something crazy. Well, I'm going to ignore the +4 for right now. Okay? And I'm going to graph that x squared minus 9. Well, I know that the y-intercept's going to be down at -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Down there. I know that my x-intercepts are going to be where? If I factor that x squared minus 9. Yeah, it's going to be at 3. So 1, 2, 3, and 1, 2, 3. Like so and like so. So that is what that graph looks like. Like so. But if I take this 4 into account now, what is that doing for us? What would that do to the whole graph when you look at that now, the +4? What's that going to end up doing to our whole parabola here? Moving it which way? Yeah, up 4 units. So every point we have is going to go up 4 units. You know, so let's ignore it for now still. Let's go and do the absolute value in green here. It's going to be good here. This 9 is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's going to go up like this and down. But I have to remember, really, which way is it going now? With that 4 in place, I'm going to move everything. No, I'm going to move everything up 4, right? Which in essence is going to push everything that way. So let me see here. It's going to go up here, 4, up here, 4, up here, 4, and our real graph. Well, you can, but I'm just trying to show you what it'll do. And like I say, best way to do it, table of values, right? Just to double check. But it's that easy. So anything that's negative, once you take the absolute value of it, becomes positive. Positive never changes really, right? Questions? Concerns?